Okay, today's lecture, the topic is called Measures of Variation. All right, and what I would like to do is jump right in with an example, okay? So let's say I've decided that I really want to work out, do some bodybuilding, and add some muscle mass, okay? And the way I've decided to do that is I want to take supplements, okay? So I'm going to decide between two supplements. The first one is called the Hulk's powder. And the second supplement is called Mass Gainer. All right. Now let's say I have access to a small sample of people that have used each of these and their results, okay? So let's take a look at a small sample here. We have 5 people that use the Hulk's powder, and this is what happened with those 5 people, okay? So 5 people for Hulk's powder. The first person gained 7 pounds of muscle mass. Second person was 6 pounds, third person was 5 pounds. So person number 2, 6 pounds. Person number 3, 5 pounds. Person number 4, 6 pounds. And person number 5 who used it also gained 6 pounds of muscle mass. Okay, so this is my sample of the people that took Hulk's powder. Now let's go over here and look at Mass Gainer. Again, we have a small little sample here, 5 people. The first person was 0. Second person was 1 pound. Third person was 18 pounds. And the fourth was 2, and the fifth was 9. Okay? So Hulk's powder people versus Mass Gainer people. All right, so this is my data. The first thing that I would like you guys to do is find X bar for each. Okay? What was the average amount of muscle gain for each of these examples? So remind me, how do I do average again? You just add them up and divide by how many there were, right? So in each case, there's 5 really small samples here. Hulk's powder, what did you get? 6 pounds. Okay, great. And what about our people on Mass Gainer? 6 pounds. Okay. Now let's say you are a consumer like me who's really excited and interested in adding some muscle. Okay? You have these findings, you have these results. Both claim, hey, if you use ours based on an independent test, we had an average gain of 6 pounds. Okay? And that's true based on these findings. Which one are you going to use? The first one, probably. Why? Way more consistent, right? So we've looked at some statistics. One of the first statistics we looked at was the average or the mean. But in both cases, the mean here is the same, but it doesn't tell the whole story, right? This is a very consistent set of data that's right about 6 pounds every time. This one's all over the place, right? Does everybody see that? So that brings us to today's lecture, which is we're looking at variation in the data. Okay? So there's 3 measures of variation. The first one, believe it or not, we've already looked at. Three measures of variation. The first one, range. remind me how the range works. Highest minus lowest. Okay, that's it. Great. The second measure is termed the variance, which is something I will show you how to do in just a minute. And the third one, we just kind of heard the name, standard deviation. Okay? All right, now what I'd like you to do is put a little s here, just to remind us. Lowercase s stands for sample standard deviation, okay? Sample variance is simply s squared, okay? So this is great news for us because if you know or you can find the variance, then you can get the standard deviation, okay? Similarly, if I know the standard deviation is, say, 3, then what does the variance have to be? 9, okay? So one is the square of the other, and then vice versa. One's the square root of the other. And that always holds, okay? So that's great for us. All right, a couple of things. So s squared is sample variance. S is sample standard deviation. I'm going to abbreviate that. Sigma squared is population variance. And sigma is population standard deviation. Okay, so these are some more symbols to add to your growing list of statistic symbols. Okay, let's take a look at an example of finding the variance kind of based on the definition of the variance, okay? So let me write this definition down. Variance is the average of the squares of the squares of the difference each value is from the mean. The average of the squares of the difference each value is from the mean. Okay? So let's do population variance first, because the sample variance has just a slight little different formula. So here we go. Population variance is going to be summation. Again, we're adding stuff. What are we adding? Each x value minus the population mean, mu, the square of that divided by how big, how many were in that thing, okay? I'm going to use a capital N because it's population. And that's my formula. Okay? Now again, it's very, very rare that we're ever in this class going to use the whole population. So what we're going to look at is this formula, S squared. This is our sample variance formula, which is the one that we're going to utilize. Okay? So adding up all of the x's, what is the mean when we're talking about a sample? It's not mu, it's what? X bar. Okay? And there's one small difference in the formula for a sample. Instead of the bottom being just n, it's n minus 1. Okay? So this is the formula that we're going to utilize because we're dealing with samples almost always. All right. Enough messing around. Let's go ahead and do an example.
And that's called the sample variance equation?
That's right, the sample variance. Okay, let's say we have these numbers, 10, 60, 50. 30, 40, 20. Okay, nice little small data set, nice numbers. And I'm simply asked, what is s squared? Okay? All right. Well, if I look at this formula looks a lot more complicated than it actually is. What is something in this formula that I'm going to need to find? X bar, right? We know how to do that though, right? Don't we? Let's find it then. Calculate x bar and tell me what it is. So find the average again. Add those numbers up. Divide by 1, 2, 3, 4, 5, 6. There were 6. 35. What's it come out to?
35.
35. Great. Okay. All right, what I'd like you guys to do is make a couple of columns with me. So the first column, I'm just going to write down these x values. So we have 10, 60, 50, 30, 40, and 20. Okay? The next column I would love for you to write down is x minus x bar. Okay? So I'm going to go to each x value, and I'm going to subtract x bar, which is 35. Is everybody with me on that? So you're going to get some negative numbers, you're going to get some positive numbers, but we're just going to list these out. Okay? So for instance, I'll get you started. What is 10 minus 35 going to be? Negative 25. Great. And then start listing out the rest of them. Okay, so double check that I did this right. Did you guys get negative 25, positive 25, 15, negative 5, 5, and negative 15? Great. One more column. This time, we'll call this column x minus x bar quantity squared. So if I'm just squaring this, you just take each of these numbers and square them. What happens when you square a negative number? It's positive. So you should have all positives when you list this out. Okay? So go ahead and do that next. It should be all positives. So 625, 625. 15 squared is what? 225, right?
Yeah. Yes.
25, 25, and 225. Okay. So double check you have 625, 625, 225, 25, 25, and 225. All right, now this top portion here, summation, add up all of the x minus x bar squareds. Well, this column here is your x minus x bar squareds. So if I put a big thing here and I add that up, that's going to be what my top number is, okay? So once I find that number here, that will be your top number, okay? So add those up, guys. Tell me what you get.
1,750?
1750?
Yeah.
Okay, great. I will take your word for it. We're finally then almost done with this problem. So s squared is 1750 divided by n minus 1. And what is n minus 1 here? What is n? How many numbers there were? 1, 2, 3, 4, 5, 6. So 1750 divided by 5. Okay? So go ahead and break out your calculator. And what is 1750 divided by 5? What is it? 350. So that's my s squared. Okay? Then they might say, okay, great. What is the standard deviation then? So if s squared is 350, what is s? The square root of 350. That's probably not going to come out to be a perfect, beautiful whole number. So let's go 4 decimal places. Okay, let's agree to all go 4 decimal places. So what do you got? 7. 18.7. Keep going. 082. Is that to 4 decimal places?
In round, it's
083.
083? Okay, that's fine. So we can round 083. Great. So that's what I would like to see. We're going to go 4 decimal places on all of those. Okay? Okay. Now, on your first test, you will have to go through finding the sample variance and standard deviation by hand. Okay? There's good news and bad news. Good news is that there's 2 different formulas, and you can use whichever formula you prefer. Okay? This is kind of the formula by definition. We're going through each one, and I'm going to show you another formula that we're going to use right now. It's called the shortcut formula, and I'll show you why when we do it. Okay? So your other formula for finding s squared is this. So this is formula number 1. Here's your other formula, called the shortcut formula. Summation of the x squareds minus summation of the x quantity squared over n all over n minus 1. Okay? Now, it might look worse for a second, but it's actually easier. Okay, so looking at this formula and looking at this formula, what is something we had to find in this one that we didn't have to find in this one?
X bar.
X bar, the mean, right? Now, I gave you guys a really, really nice set of numbers that had a really, really nice mean. It was 35, right? That's not always going to happen. In fact, a lot of times when you find a mean, you're going to get a lot of decimals, okay? And can you imagine the nightmare of going through and being like, oh, 10 minus 35.38926, and then squaring that? Does everybody see that, how that would be a nightmare? So the good news in using this formula is you don't have to calculate x bar, and you don't have to worry about that, okay? All right, so how does this example work? Well, let's take a look at our x's again. Let's just do the same numbers. And I want just these 2 columns. I want an x column where you just list out your x's. And then the second column, I just want you to list out your x squareds. And that's it, okay? So just do those 2 columns. Same numbers that we had before. $10, $60, $50, $30, $40, $20. And then in the next column, I just want you to square each of those numbers. All right. So just double check that everybody has this for my x column and my x squared column. Okay? Now there's 2 pieces of information, and we really want to be clear on the differences. This one here is summation of the x squareds. summation of your x squared column, okay? So if I do a little row thing there and I'm adding up all of these, this second column, that is going to be your summation of the x squares. Okay? So go ahead and add those up for me and tell me what you get.
9,100.
I'm sorry, say it again?
9,100.
5,100?
9,000.
Oh, 9,100? Okay. So everybody agree with that? 9,100? Now over here, what I'd like you to do is add up the x's. So if you sum the x's, that's just going to be sum of the x's. So that makes sense. Sum of the x, right? So add that up. And what do you get? 210. Great. Okay. Now we are ready to go into this formula, believe it or not. So s squared, the summation of the x squareds, 9,100, right? Summation of the x squareds. Minus summation of x, 210. Quantity squared, so I'm going to have to square that. Divided by n is how many were in the sample, and we had 6 in the sample. And then all of that divided by n minus 1, 5. Okay? All right, so in your calculator, be very careful here. Do 210 squared first. Hit enter. Divide that by 6. And you get 7350. Okay? Is everybody with me on that? So you have 9,100 minus 7350. Do that one in the top first, and then hit enter, and then divide by 5. And you get 350. Okay? That is your shortcut method for finding the sample variance, and then of course you take the square root of that to get the standard deviation.
You're going to want us to do both on the test.
No, one or the other.
All right.
Yeah, so whichever you prefer. Hopefully most of you would prefer the second method, but you can use the first method as well. Okay. I think the first one's easier to understand maybe, and the second one, because the formula is a little bit more complicated, but it's a shortcut. It's easier to get to. All right? Questions on variance or standard deviation?
Is there any time when the first formula you taught us was would be better than the shortcut?
I wouldn't say better, but if you had a really nice mean and that formula makes more sense to you, then in that case, right? Okay. Okay, great.